In this video, we're going to take a look at identifying and writing quadratic functions from data. The first thing that we want to be able to do is identify if a set of data could potentially represent a quadratic function. Well, how we do that is what we're going to do is look at the x values, and those x values need to have a constant change from one to the next. Then we look at the y values, or the f of x values you could also use, and for those we're going to look at the second differences. So let's take a look at how exactly we'll do that. So first of all, I want to verify that my x values have a constant change. So as I look at these in the first group here, we go -2 to -1, -1 to 0, 0 to 1, 1 to 2. So it appears we're going up by 1. So we're good to go there. Then what I want to do is find the first differences for the y values. So what's happening here, 24 to 12 would be -12. Then 12 to 3 be -9. 3 to -3 is -6. And then -3 to -6 is -3. That's the first differences. Now, if you come up with first differences that are constant, well, that would be a linear situation. But we don't have that here, so we keep going to the second differences to see what we get. So now, how do we get from here to here? Well, that would be 3. Difference between those is 3. Difference between those is also 3. So the second differences are constant, so this one is an example of a quadratic. Yes. Okay? Let's take a look at this next one. Again, we want to look at the x values. Those need to be constant. So +3, +3, +3, +3. We're good to go there. Okay, then look at the y values and see what we've got going. So we take the first differences. So 10 to 4 is going to be -6. Then we've got 4 to -1. 4 to -1, that would be -5. Then -1 to -5 is going to be -4. And then this one we've got -5 to -8 would be -3. Okay, so the first differences, we see that they are not constant, so it's not linear. So then let's look at the second differences. So the difference between those two, well, that would be 1. Difference between those two is 1. Difference between those two is 1. So the second differences are constant, so that means this is an example of quadratic. Okay, let's take a look at this last one. -2, 0, 2, 4, 6. Excuse me. The x are constant, so we're good there. Then the y's, let's check those. So 18 to 10 is going to be -8. 10 to 6 is -4. 6 to 2 is -4. And 2 to 1 would be -1. Okay, so the differences between those, well, that would be 4. That would be 0. That would be 3. Second differences, not constant, so this is not quadratic. Okay, so then once we've checked the data, we can come up with a quadratic function that would represent the data. So let's take a look at this first set of data, and I'm going to focus on, we just need 3 points to come up with a quadratic function for that data. So here we are. I've got 3 points from that first set that I know is quadratic. Now, here's what we're going to do. We're going to use the standard form, which remember is f of x is equal to ax squared plus bx plus c. Okay? So then I know an x and a y, and remember y is the same thing as f of x. I know those, but I don't know a, b, and c. So, well, if I have 3 variables that I don't know, if I can come up with 3 equations, I can solve that system and then know what my A, B, and C are. Okay, so what I'm going to do is I'm going to fill in each of these ordered pairs into this so that I come up with 3 equations. So let's see here. Let's get started with that. So this first one, we've got x is 0, y is 3. So this piece is going to be 3 equals a times my x is 0, so 0 squared, plus b times, again, x is 0, plus c. Okay? And after we write all 3, then we'll come back and do some simplification. Okay? Let's grab the next one. So we have negative 3 going in there for the y. Then a times x, my x is 1. So it's going to be 1 squared plus b times 1 plus c. Okay? And then finally my last ordered pair. Like so. Okay? Then I'm going to simplify. I can do some cleaning up here. So I'm going to change colors to rewrite these. And let's clean them up rewriting. So 3 is equal to 0 squared is 0, so that whole thing is 0. That's 0, and I'm just left with c. Clean up these second two. Negative 3 equals 1 squared is just 1 times a. So we've got a there. B times 1 is just b plus c. Then, for this last one, I have negative 6 equals 2 squared is 4 times a. So 4a. Then b times 2, so plus 2b plus c. Okay, so now I have a system of 3, and notice what I have right here. It tells me c equals 3. Nice. So then I'm going to be able to take that and put it into actually both of these, and then start and see if I can't figure out what's going on for the other, the A and the B. Okay, so I'm going to go ahead and rewrite these again, but this time I'm going to replace the C with 3. Okay, so let's go ahead and do that. So I'm going to start with this one right here, replacing the C with 3, so it'd be negative 3 is equal to A plus B plus C, while C is 3, so plus 3. Okay, then what I'm going to do in this one is I'm going to solve this for one of those, because I know the C here is 3, so if I can solve for one of these, I can insert that into this equation for that variable, have an equation with just one variable that I can solve, and then work my way back to find the other one. So let's go ahead and solve this for, let's solve it for A. So first of all, I need to subtract b here, or 3, excuse me, subtract 3, and while I'm at it, I'm going to subtract the b as well, just so we can save steps here. So negative 3 minus 3 would be negative 6 minus b, so negative 6 minus b is equal to, the only thing left over here is a. Okay, so I've got my a. I can take this then and insert it into this equation to figure out an equation that just has a's, or just has b's, excuse me, in it. So I'm going to take that one, and I'm going to change colors again to try and keep some things separate here. So now I'm going to take this equation and insert my a and c in there. So it's negative 6 equals 4 times a. Well, I solved and got a to be this. So negative 6 minus b, then I've got plus 2b, and then I know c is 3, so I'm going to put that in there. So plus 3. Now, notice, all I've got for variables here is b's. Perfect. So that's going to allow me to solve for that b. Alright, so we got to clean up a little bit, distribute. And then we'll combine like terms. So we've got negative 24 plus 3. It's going to make that negative 21. Negative 4b plus 2b would be negative 2b. Okay, then we'll add 21 here. So plus 21 plus 21. 21 minus 6 would be 15. So we have 15 equals negative 2b. Then divide by negative 2. And we end up with b being equal to negative 7.5 or 7.5. Okay, so now I have my b and c. I need my a. So this equation, I can go back to this one and plug in the b and c and solve that for a. So one more color change here, and let's see what we can come up with for the a. Okay, so I've got negative 3 is equal to, I don't know a, but I do know b and c, so I'm going to put those in. Negative 7.5 plus 3. Okay, then negative 3 equals, so I can combine this stuff right here, and that's going to give me, let's see, negative 7.5 plus 3 would be negative 4.5. So minus 4.5. Then we're going to add 4.5 to both sides. Plus 4.5. And we end up with a is equal to positive 1.5. Okay, then my final step is going to be to take the a, b, and c and insert those back into my standard form equation, or my function, so that I have the function that represents those three ordered pairs. So it's going to be f of x is equal to a, which we found to be 1.5, x squared, then b, here's my b, negative 7.5x, and finally my c, which is 3, so plus 3, and there it is. Okay, this function right here, if I were to graph that, would go through these 3 points. Okay, so quickly to review, if we want to identify quadratic data, what we want to do is look for the second difference, and the second difference of the y values has to be constant. If it is, it's an example of a quadratic situation. Also remember that the x's need to be constant. So second differences are really key. Then, if we have some data that we know is quadratic, we can write a quadratic function that would contain those 3 points by using standard form, filling in 3 ordered pairs for the x and the y, as we did here. Then we can simplify, and remember, when we have a system with 3 variables, it takes 3 equations, and we can work that through to get the a, b, and c, which finally we fill in to get our function, again, that if we would graph that, would go through all 3 of those points, or if we put those in, those 3 would all work. Hope this video was helpful. Keep working hard on your math. Even this stuff you can do if you work hard at it.